Now you're
Good. Okay, cool. Alrighty, just taking a moment to let your shoulders fall. And soften your jaw. Letting your breath be easy. Paying attention to the sounds in the room, including my voice, the sounds in the hallway. Can you let those just fall on your eardrums without processing? Notice that there's other sounds in the room too. There's a higher pitch sound. Can you let your shoulders release just 10% more? Not forcing them, but just letting them go. Just in the last few minutes here, noticing your breath, not trying to control it. Not getting too tight with your focus either, just noticing that you're breathing. And very gently coming back. Getting ready for calculus. Hey. Now I'm going to close. I'm starting to like, wow, I saw like I don't know, I was like, there's an S in here. Like, I'm not on drugs, but it feels like it, because there's like letters appearing in that. So, as far as you know, it's all that matters. Alrighty, so. Home stretch, my friends. Home stretch. Last little bit here. There's a new web work opened up. Oh, actually there's two web works. So there's an extra credit web work that should be opened up. And it is due, did I see a yay or something somewhere? Yes. And it's, I'm gonna open a series of them. So this is like, maybe like 10 integration problems. So it's like integration by substitution, basically. So note that's what you want to use, substitution. If you're going to do that extra credit, do as much or as little as you want of it. You still get credit for doing any of it. It's not like one of my brutal do it all or die kind of things. So there's that, and then there is a web work to prep for the exam, the final exam. Final exam is just going to be over series and sequences, just this last stuff. There'll probably be a little bit of integration on it just because I want to make sure you can do an integral of some kind, like a simple integral. So there'll be one like, use the integral test. Part of this is going to be take home. So on Wednesday, I'm actually going to give you a take home component to the final exam. You'll get time to write it up. I want you to like be able to like think about it and work on it and make it real pretty and understand what's happening. And part of it might be that web work assignment that's up. So I would do that web work assignment to prep for the exam, but it might also count for part of the exam as well. What I would like is that when we get here on Wednesday, what time is it? Do we meet at 1:10?
1:15.
1:15. 1:15 next Wednesday is our final in here, from 1:15 to 3:15. I would like that to be a very simple thing and not a grueling thing. So like, I'm gonna give you some take-home parts that will be very involved. You'll have to do a lot of writing and stuff. I don't want the in-class to be like that. And I might even give you like a practice version of that so you can get ready for it. Does this all sound good? What? Yeah.
Does the take-home part, can we like consult it?
You can absolutely consult with me. And I'll probably give it on Wednesday in class, and then we can work on it Wednesday and Friday in class. And I'll have office hours of some kind on Monday and Tuesday of next week. I might just like make an appointment with me, and we'll just meet and talk about whatever, something like that. Yeah, or something, or I'll have a problem session that I'll record or something like that, or something. I'll do a bunch of stuff for you. I'll do everything I can for you to make sure that you can just totally ace the exam. Because if you ace the exam, I'm done grading faster. Don't think that that is not a motivation for all your professors. Okay, so some of them are real masochists, though. Some people are. Yeah. Yeah. Some people just want to suffer. I don't want to suffer. I'm not the suffering kind. At least I'm not suffering like this. I like to suffer in certain ways. I like to sit still for 4 hours. That's suffering, trust me. But I don't want to make you do it. Alrighty, so last bit, power series. And this is where things get cool. Oh God, all my blabbing killed that beautiful pen. This is like basically what I wait to tell you about even when I meet you in Calc 1. The minute I meet you in Calc 1, I think, I hope they take Calc 2 with me so I can tell them about this. Today's the day. So, power series. It's an infinite series with an arbitrary form. So notice here, that is an x. That is a variable to the nth power. These are coefficients. So this is a constant coefficients that depend on n. So constant coefficients that change with n, that depend on n, but they're numbers. Depend on n. And then this x is a variable. Excuse me. So in some ways, this is a function of x. Thanks. Yeah. Thanks, Lou. Let me get that out all the way. For different values of x, this thing's going to behave differently and produce different results. So there's this, or there's a more general form, and I'll relate them in just a second. You have the coefficients, but then you have x minus some fixed number to the nth power. So this number that I'm subtracting off here is called the center. So x naught is the center of the series, of the power series. What's the center up there? This is of that form up. This one, nope. What is being subtracted from x before I raise it to the nth? Yeah, so check it, yes, exactly. So check it out. This one up here is really of this form. That's what I'm trying to say. So this one has a center at 0. So when you see a series like this, the center equals 0. Yeah. Let's see. So this series will converge for certain values of x. And it will diverge for others, maybe. The range of x values that give convergence are interval of, comprise, how about we say that, comprise the interval of convergence. Let me slow down. Look for a snack really quickly. It's okay. It's an okay snack. So the intervals look like this. We have the center of the series. Oh boy, that is piss poor. It's a little better. Okay, there we go. So here's the real number line. So this is the real number line. And here's the center of the series. Notice that when x equals 0, what do you get out of the series? When x equals 0, oh, excuse me, when x equals the center. So here, if I replace x with x sub 0, what does that turn into? 0. Yeah, so notice that when I let x be the value of the center, you've got x naught minus x naught, you've got just 0. So the series always converges at its center. So let's actually make a note here. At the center, the series, and let me write this out if that didn't quite make sense, looks like sum x naught minus x naught to the end. Oh, put the little coefficients in front. Looks like this, but that's just 0. A sub n times 0 to the n, and that's just 0. So the series always converges at the center because it's just dead at the center. It's 0 at the center. And then we're going to get different values as we change away from that center. And we can move out a certain distance away from the center. So if I can move r units to the right and r units to the left, that's called the radius of convergence. So all the values inside here, the series converges for. And this r is called the radius of convergence. So let me write that all out. The radius of convergence, r, is the distance we can move from the center and still have convergence. Have the series converge. And once we get some solid examples, this will all feel a lot better. Let's see what else. I'm just getting some of the basic terms down and then we'll just start playing with them. Yeah, let me give you an example. I think that'll be good, because you know what I'm talking about. So example. Better work, Penny. Here you go. Say I've got a series that looks like this. That is x plus 3 to the n. If there's any doubt, and there could easily be. Let me look for some other buddies in here. Made it through this. Oh, shit. Yes. Okay. So we got this series. If I told you, suppose the radius of convergence is 4. Where's the center?
-3.
Beautiful. Lovely. It was a trick. You got it. Nice. So notice that the original series looked like this, the one where we called the center. The center. Here we're subtracting off -3. So here we have x minus -3. Let's make that little note. So here the center equals -3. And then the interval of convergence, I would draw these out when I'm thinking about them. It definitely helps. So here's -3. I can move 4 units to the right. And I can move 4 units to the left. So what's this point here?
1,
Thank you. And
-7.
-7, yeah, beautiful. So the interval of convergence is going to be, now notice how I'm not including the endpoints, because we have to test those separately. Just trying to put some of these things together. So leave open until we find out more about the endpoints. And the endpoints here are -7 and 1. So right now my interval of convergence just kind of looks like this. This pen is really upsetting me. Feel the tension building. Oh yeah. That's what I thought about the last one though. I hope I'm not betrayed again. Okay, so basics, just the basics. How do we find the interval of convergence? This is the problem. This is it for the rest of the semester in some sense. This is the hardest thing we need to master. How do I find this interval of convergence for a given series? And then I need to know a few special series, and then I have a beautiful story to tell you later this week. One of my math stories that I love to tell. So, how to find, and then we're going to do this. I'm going to give you the algorithm, and then we're going to do it. The interval of convergence for a series for that power series. How do I do that? Step 1. Let R inverse, so this is actually 1 over the, what we're gonna do here is actually gonna find 1 over that thing. So let R inverse equal the limit as n goes to infinity of the ratio of leading coefficients here. So just the numbers in front of the powers of x. Does this look familiar, like one of our tests?
Is that an an plus 1 or an plus 1?
Yes, that's a good question. So that is the sub is plus 1, because this is the ratio test, right? So basically we're just using the ratio test here. And we're gonna crank that out, and that's the reciprocal of our radius of convergence. That's it. Let's make a few notes. So first off, notice that R itself is actually the reciprocal of that. And so whatever we do when we crank that out, we're gonna have to take its reciprocal. That's okay. If this limit here equals 0, 1 over 0 you can think of as kind of infinity. So let's make a little note here. If R inverse turns out to be 0, like at this stage here, then we say the radius of convergence is infinity. And every value of x works, and all real x values are valid. So an infinite radius of convergence means, hey, you still got a center, but you can move as far away from that as you want. Everything is fair game. Good to go. If this value turns out to be infinity, then the radius of convergence is 0. And that means the series only converges at its center, and you can't move away from it at all. And series only converges at its center. So let's do some examples now. Oh wait, no, that's step one. Step two. Step one is find the radius of convergence. Step two is now find, so use the center to find the interval of convergence. And I'll just give you a formula for it. The interval of convergence is going to be your center minus your radius up to your center plus your radius. So if this is x naught, here's x naught plus r, here's x naught minus r. Those should be a little more symmetric than they are, but that's okay. So right now, just the abstract, and then we're gonna go through this like a bajillion times together. Step three, notice how these endpoints are open right now. Step three, test the endpoints. So those endpoints are x naught plus or minus r. And this is if r is finite. If r is infinite, your endpoints, you're good to go. You don't have to worry about there are no endpoints. Everything is good. So test the endpoints. What do I mean by this? So plug, i.e., plug x equals x naught plus r into the series. And what is that going to look like? Let's think about it. It's actually going to look like this. So you've got your arbitrary coefficients. When you replace x with x naught plus r, you get x naught plus r, and then you had a minus x naught to begin with, to the end. And the series is just going to look like this. Test that for convergence. This is going to be a number now. This is a number, this is going to be a number. You test this. Does this converge? Then test the left endpoint. And I'm going to stop this algorithm right after this in a similar way. I'm not even going to put the similar way. And I'll show you what to do with it as we, this is the rough outline. The details will come up as we do this shit. So let's do this shit. So these power series are just infinite polynomials. And I shouldn't say just, because that's a pretty heavy thing, but they are infinite polynomials. We're just trying to get a handle on them. So example one. And here I'm going to start at 1. It doesn't matter where you start, it's all good. So let's write out what this series looks like. You won't be upset with this. Put an exclamation point and change that to 0. Let's start off chill. This is much chiller. This is like, you need to know this one anyway. This is like one of the great series of all time in the world. So what does the series look like? Can you just take a minute and write out the first few terms to make sure you understand what that thing holds inside? that means we don't have some basic problems, which would make the rest of this almost like worthless. So that's good. That's really freaking good. All right, what's the center?
Zero.
0. When it's just x to a power, it's just 0. You have to have x plus or minus something to have a non-zero center. Cool. So let's do step 1. Our inverse is going to equal limit of, what's a sub n, by the way? Gotta be careful here. So you might want to write the series like this, because this is the form I wrote it in. Notice how I pulled that x off top, so that it looks more like the thing that I put up, the template. What's a sub n? What's the coefficient on the nth power of x? Banana bar. Cool. Starving.
Wait, what was the question? Over the n.
Thank you. 1 over n factorial. Yeah? It's just the thing, it's the expression that involves n in front of the x thing. Let's write this out in the way that we practiced. So it's actually a to the n plus 1 times 1 over a to the n, right? And then that is limit as n goes to infinity of, what's a to the n plus 1?
1 over n plus 1 factorial.
Beautiful, Lou. Thank you. Yeah, just take this expression and replace the n with n plus 1. Awesome. And then what's 1 over a sub n? What's the reciprocal of this?
N factorial.
N factorial. Thank you. Very nice. Factorials abound with cancellation, right? If I just write this, can we, is this going to be cool that this is just 1 over n plus 1? Do we see that? I'm happy to explain it if we want to see it.
So you cancel the factorial?
Not the factorial, I know what the factorial means, so let's think about it. So the top, n factorial is this. Yeah.
Oh, right.
Right? And then n plus 1 factorial is that taken out a step more. Right? So this is n factorial over n plus 1 factorial equals this. And see how all that beauty cancels?
Mm-hmm.
And I'm left with just 1 over n plus 1. What's this limit?
0.
Hell yeah. Fixed thing over something blowing up, right? Like that's the story of this class, isn't it? Like I tell that story every week, I think. So R inverse is 0. What's the rule then? What's the radius of convergence? Infinity. Beautiful. I don't have to test endpoints. Yay. This series converges no matter what x you put in. So let's write that up so we understand that this series converges for all x values. No limits. That's cool. Let's do one more. Let's do a fun one. Hey, well, let me give you one. What if I twist it up a little bit? Can you please find the radius of convergence, my friends? plus one's left. N factorial kills off all the stuff underneath n plus one. That goes to infinity. So r equals 0. What is the center? Also 0. Yeah, center 0. This series only converges for what x value? 0. So the series only converges. This n factorial blows up so fast that if you put anything else in for x besides 0, it just explodes. It only converges for x equals 0. I'm going to write out what the series looks like real quick. And I'm just doing the factorials here. Those coefficients blow up so fast that any x, even like a hair, the tiniest, the wafer thinnest x, will just explode that thing eventually. Cool. All right, let's do, okay. Yeah, I know which one. Next one. That's the one we want to do. So, I'm going to give you this one and ask you to try it. Just find the interval of convergence first, and we're going to have to test endpoints, so don't go to that stage. Let's do that together. So find the interval of convergence. We've got to start at 1. So this was the one I was going to put up before. I'll just write it out all friendly like.
Is that a 1?
That is a 1. Yeah, the starting index?
Yes.
Yes. I am going to change one thing. It won't affect anything that you're doing yet. You haven't gotten there yet, but just make that. It won't affect the our work. It will affect the center. So one of these should still be a fraction. This one's still a fraction. That's the problem. So an plus 1 is actually 1.
Oh, shit.
Yeah.
Okay.
If, otherwise, it would have been right.
Okay.
Yes. Yes. Very nice. Yeah. Then come up with the, what is the actual interval, the initial IOC? What you got R is, what's the top going to? What's the bottom going to? So, there you go.
Yep.
There you go. Yes. Lovely. And then once you get that R, which lots of folks are, folks, the Chinese folks. Okay, so, yeah, this is not so. You just want that in front, the one.
Just that one?
So if this is, so I would, do you mind doing
Yeah.
this real quick? I would write it out. Oh gosh, thanks, yeah. So a sub n is that number in front. So what is a n plus 1 gonna look like? There you go. Okay, does that make sense?
Yeah.
And then one more thing I'm gonna tell you, because I see trouble of brewing here real quick. This is this. use that. It'll keep you safe. Does it feel good? What happened? So we lost an N. Let's try it out. Can we,
Oh, yeah.
yeah. So just a little slower here. So this is a sub n plus 1 times 1 over a. So you forgot
Yeah.
that part. Yeah. How you doing, man? Nurse. Yes. Babies. Yes, indeed. All right, let's take a look. Okay, this is good. Good setup. But I'm gonna recommend you do this. So, all right, first use this form. Keep it from have to deal with that. So we do a n plus 1 times 1 over a n. So that's the same thing here, but it'll help you simplify that. So what would that be here? So what would that simplify to? Because those compound fractions are messy on your head. What would this look like here? Yeah. And then what's that? Here, go ahead and write that out. This is too good. Yeah, what's that limit as n goes to infinity? What's the top doing by itself? So where's the top going? Growing. What's the bottom doing? Yeah. So you got infinity over infinity. We've got a couple ways to deal with that. You could L'Hopital it. You could look at the leading coefficients. There you go. That's it. That's it. How's it going? That's good. Yeah, solid. Yeah. Okay. There's my damn pen. All right. So. And I'm recommending this to a lot of people. Write this formula out like this to save your brain a step. Especially because fractions just seem to be a problem for a lot of folks. See how nice that is when I do it like that. Then I don't have to like, multiple fractions within fractions. That shit just gets crazy. So it's lim, n goes to infinity of n over n plus 1, and that is a solid 1. Yeah. So then my center is 2. Right, so x naught is 2. So here's the center. Draw the number line out. Move 1 unit to the right. So here's 3. And then 1 unit to the left. And that's 1. So and I'm going to call it my initial interval of convergence is equal to 1 to 3. And I'm going to leave open endpoints there. So that's the preliminary. Now we have to test each endpoint. So let's do that together. So now test the endpoints. So first I'm going to test x equals 1. And I plug that in. I literally rewrite the whole series and do some algebra. So plug x equals 1 into the series. And you're going to get this n equals 1 to infinity 1 over n, and so you're replacing the x. So let me just be really explicit when I'm doing that. So that becomes 1 minus 2, and so that's, what does that simplify to? Thank you. To the n, right? Yeah. What kind of a series is that?
Alternating.
Alternating series. It's an alternating series. Bounces back and forth, plus minus. So this is an alternating series. Does it converge? So what is the non-alternating part? It's this. What do I have to check? What does the AST, alternating series test, want me to verify? Yes, I see lots of like,
Is it whether it converges like absolutely or conditionally?
Yeah, that's like a more meta, like part of the process, yeah. What is the AST? What does it say? The series converges, an alternating series converges if, there's
Oh.
two things.
And if it's like decreasing or like.
Decreasing and,
No.
yeah, so if this part's decreasing, as n gets bigger, is this decreasing as n gets bigger?
Yeah.
Yeah, because it always is, right? I told you that's always gonna be the case, we don't need that. Then what's the other part?
Converges to zero.
0, yes. So we got two parts, this is decreasing and it goes to 0. So the AST, let's put a little question mark here. 1 over n, decreasing, check. 1 over n converging to 0 as n goes to infinity, check. This series converges. Cool. Does it converge absolutely? No, that's a good answer, Gassy. Why?
Because it's the harmonic series.
Oh my
so that
God,
one diverges.
you bowled me over. Oh, so happy. Oh, fuck, that is awesome. Thank you. Holy shit. You guys know stuff. This is so awesome. This makes me so happy. Oh my God. Yes, it does not converge absolutely, because absolutely, this series, so converges, but not absolutely. Because the absolute series is the harmonic series, just like Cassie said so eloquently. Is the harmonic series. Does everybody see that part, that if you take off the -1 to the n, it's just 1 over n? It's a p series with p equals 1. So the absolute value, let me just put this here because I see a couple, like, absolute series is this. Oh boy, that's hard. Okay, I'll just fuck it, that's it, sure. That is a sad ass sigma. The haunted sigma. Is this. Oh my God, that looks so bad, but that's the harmonic series and that diverges. So what we say, it's conditionally convergent. So this series is conditionally convergent. So here we go to 1 and we put a little circle here and we just make a little note that it's conditional at x equals 1. Could you please test the other endpoint for me? Yeah, okay, Cassie,
So
yes.
for that one, so like we wouldn't close the bracket because it doesn't include 1, it
Correct.
includes the numbers before 1.
Yes,
Okay.
that is correct. Yeah, because usually what everything inside here is absolutely convergent because we slapped absolute value signs on. So all the stuff in here is absolutely convergent.
Okay.
So yeah, it's conditionally convergent. It's like,
So you say it's conditionally convergent.
at x equals 1. Yes. Now test me some x equals 3, please. sum sign in front. That's freaking awesome. Should have the series expert back here. No pressure.
Yeah. So, not this, but because, so what series is that actually? You named the term there. So it's just harmonic, yeah, so it just, yeah.
Yeah, there's no condition, only conditions when it's alternating.
Wait, so it's the same thing?
No, because this one doesn't alternate. When I put in the 3, then this becomes +1 as opposed to the -1. What's the questions? Ask me. No? Okay.
Then why do you have 1/n there?
Well, because I had that one turned out, when we had 1 minus 2, that was an alternating series. And anytime you have an alternating series, you want to ask the question, does it converge absolutely as well? This one doesn't alternate, so it's just like, we just analyze it on its own.
So is that just like the common ratio?
Is what? I'm sorry, explain.
Is 1/n the common ratio of the first, n one?
It's not a common ratio, so be careful. That's only for geometric series, but it is the coefficient.
Okay.
How do we feel about at least what I've got up here? When I replace x with 3, this is what it looks like. And then this is just 1 to the n, that's just 1. So it's this, that's the harmonic. Or you can think of it as p series with p equals 1. So either way, it diverges, and there's no options, there's no alternation, we're not gonna worry about. This is the absolute value of the series. So it diverges. So this point, then, now I put an open circle there. And so, wait, sorry, I got this ass backwards, shit. It was conditional here, sorry, shit. Wasn't that right? Wait, oh, no, that was right. No, okay, what the fuck am I doing? Sorry, yeah, so this was conditional. I was looking at Kelby's like face and I was trying to gauge what I was doing wrong based upon it. So this is not included. We don't include 3. Because the series diverges when x equals 3. Everything's good. Yes, let's talk.
I'm confused why the circle is closed on 1 if it's conditional, because wouldn't that not include
Let me
1?
think about it.
Okay, because it wouldn't include 1, but the number is after 1, right? So
Wait, so ask that question again.
because you close the circle on the 1, but
Yeah,
it would be
but I made a little
after-
note, but with a
Okay.
note.
Okay.
But with a note, so it's like a
Yeah.
hashtag before a command.
It is, yeah. So it's like it's a hesitant closing.
Can we just keep
I'm
it
sorry.
open
You can
because it
totally-
doesn't consider, like, 1's not counted? Okay.
Absolutely.
I think the other people had the same question I did, so.
So as long as you have the note, you can put whichever one.
You got it.
Okay.
As long as I see a little note, we're good to go.
You can do whatever you want.
Do we have to do circles on the test? Like a number line?
What kind of an A student question is that?
No, like am I gonna have to like be like, oh, this is closed, this is open?
You could do either, as long as like,
Okay, great.
if it's included, if it was absolutely included, circle.
Okay,
If it's conditional, do whatever you damn well please, just leave me a note.
okay, and then, I don't know what you did. I'm confused,
Yes,
I'm just confused.
it's okay. That doesn't sound like a weird place to be.
It's like that
Okay.
that thing where it's like with polynomials, where it's like, you have like this bracket
Yeah.
as opposed to this bracket.
Yes,
Yes.
yeah, it's like that, yeah.
Maybe open is a parentheses. and-
Yes,
That's all.
yes. So like that is that,
Just like one more.
goes in the same,
Yeah.
and then closed is that, and yeah.
So I'm not confused about that.
Cool, that's freaking awesome,
I'm
outstanding.
confused
Okay,
about the P series part.
yes.
So you said,
You can confuse why it's not.
What?
Are you
Absolute.
confused on the alternating series?
I don't know why I'm confused, I'm just confused.
That's the worst kind of confusion.
So,
Do you want me to summarize really quick? Do you want me to do a quick summary? Okay.
Yeah, that might help.
Cool, alright. So, step one was we found the interval of convergence, and that was 1 to 3. You were not confused about that at all?
No.
Cool. Then we test the endpoints. We tested x equals 1, and when we plug in x equals 1, the series looks like this.
Mhm.
That is an alternating series that does converge, but it does not converge absolutely. So it's like not a strong convergence in a
Because
way.
it's not a harmonic?
Well, it's not harmonic with the alternation, but when we take the absolute value, it turns into a harmonic, which is a divergent series.
Okay.
So hold on, so let's look, so slow back. When I plug in x equals 1, the series looks like this. Just don't even look, don't jump ahead,
Okay,
okay?
I got that.
And then this series converges by the alternating series test.
Okay.
So we note that, we're like, oh, cool, it converges there. But then I'm like, oh, it's an alternating series, so I'm wondering, does it converge absolutely as well?
Uh-huh.
Like everything else inside here. And so I test that, and that turned out to be not true.
Okay, that's the problem. What did you use to test that it wasn't absolutely
Oh,
true?
because it's just it's a p series with p equals 1, or it's the harmonic series. So when you slap absolute values on this thing, it turns into that series.
Yeah, and p equals 1.
And p equals 1, that's p series with p equals 1, or we just recognize it as the harmonic series and we know that diverges. So the harmonic series is this one.
Yeah.
And so that diverges. And if I see that, then I just know, oh, okay, that diverges. So there was no test really used to determine that. It was identifying it as a particular kind of series.
Okay.
Yeah?
Yep.
I'm sure everybody else appreciated all that too, so that's not bad. Nothing wrong with that. Thank you. And then when we plugged in x equals 3, it was just the freaking harmonic right off the bat. Okay.
I'm
No, I'm just,
okay.
Josh is, he's had it. Josh is done with this.
No, I'm heavy yet.
No, you guys stay a little more, okay.
Would everything between 2 and 3 also be absolutely convergent?
Yeah, everything in the original interval is absolutely convergent because the way we found it was with absolute values. All right.
Okay, now I've had it.
All right, have a good practice. You know, Wednesday. Let's do one more.
All right.
Do your stuff. Knock it out of the park. Find out what's going on back there. I won't look at you. What does you want to
Sorry.
talk about? No, what can I help with?
Hard to learn at home.
Yeah, you were gone for a while.
Yeah.
Yeah,
I'm alive. I'm okay.
well, no, I can see that, yeah, and you're going to be okay.
Yeah, so, okay, it's just that sentence in the world, I don't know how to do it. So,
Yes.
do you always do the absolute, okay, so I'm guessing the absolute value, or absolute series is the absolute value of the series, right?
Correct.
Okay.
Yes.
So do you always do that,
With an alternating series.
just to check?
Yes.
Okay,
So when we have an alternating series, we always want to know, does it converge absolutely also?
okay, so by putting the absolute value
Yeah.
there, that's how you find out. if
Basically,
it's-
remove the alternation, just remove the plus minus, and then analyze the series and go, does this converge? Does that make sense?
And if it's divergent, but it's not, it's only conditional.
Correct.
Okay,
Mhm.
okay, I'm good now.
Yeah, okay, awesome, awesome. See, you're all better, so fast. So this one you should be getting Rs3. Awesome. If not, let's talk. Yeah. Get your IOC and test your endpoints. What's the face?
How did you get?
Which one? Oh,
Because if you just put 3.
So you got, that's 3 to the n power, not 3n. Yeah, yeah. But I would make that n a little more subscripty. There you go. Oh, look at that, how fast that is. Yeah, that's 6 subscripts. So this is 3 to the power of n over 3 to the power of n with one more. So it's like 3 to the 4th over 3 to the 5th, or 3 to the 8th over 3 to the 9th. There's just one more 3. So like actually, you could rewrite the bottom as 3 to the n times 3. So yeah, check that out. See, you see what I'm saying? So does that make more sense? The 3 to the n cancels.
How is 1/3 3?
well, that's our inverse, so be careful, right?
Oh.
Yeah, there you
It's not 3.
We've been talking about 1/3 is 3 for weeks, Lou.
Sure.
It's always negative. Sometimes negative 1 when you do 3
And our center's at -1, right?
Yes.
Good, cool. Yeah, looking good, Fernando? Yeah, all right. I feel like I had a 5-year-old coloring my line, but it's all good. Careful about the simplifying, just wanna make sure everybody's. Yeah, oh, yes, yes. Is that top series, the x equals -4 converge? No, it doesn't. Why?
Cause, the, R equals infinity, so it's 0.
I'm not sure I understand that. It's an alternating series. There we go. Okay. Do the terms die out? No. That's like 1 + 1 - 1 + 1 - 1 + 1 forever and ever. That doesn't, don't, remember this, the terms have to go to 0 to have a hope of converging. If the, remember the nth term test or the divergence test. If the terms don't die out, the series diverges.
Oh, so if the limit goes to infinity,
That for sure.
then the R is 0.
Yeah, but we're not thinking about R right now.
Okay.
So right now, I'm just saying that this series, the terms don't die out. The things you're adding up need to go to 0 to have a hope of converging. What about this one? This is like 1 plus itself forever. Do we see that? So these both diverge. This diverges. So here's a good tip. If you have an alternating series and it diverges, you don't need to worry about absolute because that's going to get worse. This diverges, these both diverge. And we could say here by the nth term test. I think I might have also called it the divergence test on your little sheet that I gave you. I don't know why I call it a little sheet. Cute little sheet. It's not very cute at all. So my IOC, this is it. This, your interval of convergence here is just the interval. -4 to 2. You can draw that out with circles, whatever you freaking want. There you go. You can draw it, you can write it. Lots of ways to make me happy. Yes? Yeah.
Why is that one over, or 1 to the n? How do you cancel out?
So this is 3 to the n over 1. Multiply across, and they cancel. It is 1. Yeah. Yes, it's also that. Agreed.
But it's also 1.
It's a 1 to the n. I mean, here's what I'm doing, Vivian. I'm doing this, and I was trying not to go too fast. But you're right. You're 100% right that that is what it is. I agree.
So I can still write
You can totally write that. You can write anything that's correct. I'm not going to stop you from doing that. So, if I give you a little video to watch before Wednesday, will you watch it? It won't be me. But it's some. I want to like warm your mind up for what's coming on Wednesday. Yeah. I mean, you can or you can't. You don't have to. I think it will help. So I will send you a recommended video to watch for Wednesday. It will prepare you emotionally and mathematically. Everybody. Yeah. Oh, okay. Go ahead. Check it out. I'm gonna answer Vivian's question about web work. If